two rows there, two columns, excuse me, that I would highlight, and that's under the 60% there, I'd write the word nipple across the top, and then I would highlight the area in inches square. Just take a runner, a highlighter, and just run it straight down that column there. And that way, kind of make it pop out and differentiate it. And then that far column on the very far right-hand side is the other one. Right-hand side column, under over 2 wires, 40% area in inches square. Like I said yesterday, I'm not French. I don't even know how to talk love speak in it, so damn sure not going to try to use any kind of millimeter square. So, all right, the next table over, which is table 5, is all broken down by a wire insulation type. So table 5 is the second of the two, the pair, and that's what we use in conjunction with what we just highlighted there under the nipple rule in inches square and the 40% fill. If you turn all the way back to page, where's it start? 716?
716.
That's table 5. And so all your rows have the actual insulation type, and your columns have corresponding to what you just highlighted, the farthest right-hand column, and that's the only thing I care about in table 5. All the rest of it, don't even worry about. This right here corresponds with what you just highlighted, so those are the two twin values that you compare. And then it's simply, you just find that insulation type, and then find the wire size, and all the way on that far right-hand side, there's your value of an individual conductor. And if you have 8 of whatever it is, you just multiply that times 8 and then go on throughout the list of whatever the wire insulation types that you have. So you can really look at a conduit question. In German, you will have conduit fill, flat out. So not many, but there's 1 or 2 just off the top of my head that have been recent questions that have to do with some number 8s run into the schedule 40 PVC, and it comes up into the distribution panel as schedule 80. Right? I think they tell you it's a number 8 wire fed into a residential application. They don't tell you the ampacity, or they tell you what the amperage is, and you have to go to the table and find out what size wire you would put in it, and then multiply that times however many wires you normally have in a residential feed.
And you size the conduit, right?
And then size the conduit by. So I mean, there's a couple ways that they can skin a cat, but effectively it boils down to the same thing, table 4, table 5. If you're looking for a conduit size, you're going to start with table 5 and work backwards. If you're looking for a wire size, the maximum number you can put in the conduit size, you start with table 4 and work the other direction. Well, yeah.
When do you use 100%?
You don't. I mean, that is effectively the full fill value, but unless you're a plumber, you'd probably never get there. And I'm a bad plumber. I'm the worst plumber there ever was. And, yeah, it's bad. Only in a case of having to calculate something specific for field values, but there's really not anything that I can think of at the top of my head that would even come into play. So it's really kind of more info than you need, but you could use that to calculate any of these if you didn't know it. So if you were going to write, if you didn't have much paper to write on, then you could just take that and remember that that's 60% D3 or whatever that value is. I guess would be an easier way of doing it. But all right, so let's take a quick example. Let's say that you had, I think I've got one here. I'll put it on the board so you don't have to worry about pin scratch or my makeshift board. Somebody have a question? Oh, that was blowing your nose. Huh. That's pretty funny.
They just keep coming.
Man. I'm about as good of a joke teller as I am a plumber. Let me see here. So if we had a following set of wires, and it's going to be right up, and that's it. We can break for lunch. Just see the answer. You just had it. 2 number 8 XHHWs, 6 250 KC metal THW in conductors, and 1 3-off THW in conductors. Looking for what size galvanized rigid or rigid galvanized or rigid metallic conduit. All 3 of them are manufacturer names, but RMC, rigid metallic conduit, is the technical code, what should we call it? Now, what's the word for acronym? Correct, acronym that they use for rigid. So you're going to start here in this case with table 5. and you're gonna go through and find each individual conductor size, or conductor by insulation type, and then extend it out by the number you have in each one of those particular calculations, and then add them together, and that'll be your minimum value that you use to apply table 4 to. So work it by yourselves, and kind of give yourself a chance to see how you do on one just alone.